Galileo Galilei, the man who revolutionized science. Imagine Italy, in the late 16th and early 17th centuries, an era when the world of science was still in its infancy, and many of the fundamental laws governing nature were yet to be discovered. At the heart of this scientific awakening stood a man who would challenge the very fabric of how we understand the universe. His name was Galileo Galilei, a name that would come to symbolize the marriage of observation, mathematics, and experimental science. Galileo was not just a philosopher or a theorist. He was a trailblazer who combined rigorous experimentation with mathematical precision, two tools that were revolutionary for his time. But Galileo didn't just observe nature, he sought to decode its secrets with an ingenuity that would set the stage for future scientific breakthroughs. A scientific revolution in motion. From an early age, Galileo was immersed in a world of ideas. His father, Vincenzo, was a lutenist and a music theorist, whose work bridged the gap between mathematics and music. This environment laid the foundation for Galileo's lifelong fascination with the relationship between numbers and nature. One of Vincenzo's discoveries, that the pitch of a string changes in relation to the square root of the tension, was perhaps the earliest known mathematical observation in physics, and Galileo was keenly aware of its significance. But it wasn't just his father's musical insights that shaped Galileo. His understanding of science was molded by the prevailing scholastic philosophy, which married the abstract world of philosophy with the practical insights of early experimentalists. Yet, Galileo was not content to merely follow tradition. He wanted to prove that nature itself was governed by mathematical laws. As he boldly declared in the Essaya, "Philosophy is written in this grand book, the universe. It is written in the language of mathematics." This statement wasn't just philosophical. It was a proclamation of a new era in scientific thought. Galileo's insights into motion were groundbreaking. By carefully observing the world around him, he discerned patterns in motion that had long eluded thinkers before him. He took a methodical approach, combining rigorous experimentation with mathematical analysis, a combination that set him apart from his contemporaries. His work with the motion of falling objects and projectiles would eventually lay the foundation for what we know as classical mechanics. The birth of modern astronomy. Galileo's story is perhaps most famous for his contributions to astronomy. In 1609, after hearing about a new Dutch invention, a telescope, Galileo built his own. Using it to peer into the heavens, he made a series of observations that would forever alter our view of the cosmos. For the first time, the surface of the moon was revealed to be not smooth and perfect, but cratered and uneven. He turned his telescope to Jupiter and discovered 4 moons orbiting the planet, evidence that not everything in the universe revolved around the Earth. But it was his observations of Venus that provided the most compelling proof for the heliocentric model of the universe, the idea that the Earth and planets revolve around the Sun, not the other way around. Galileo observed the phases of Venus, just like the phases of the Moon, which could only make sense if Venus was orbiting the Sun. This discovery, while confirming the theory of Copernicus, set the stage for a dramatic clash with the religious and philosophical authorities of his time, who upheld the geocentric view of the universe, where everything revolved around the Earth. He also observed sunspots, studied the Milky Way, and documented the irregularities of the stars, marking the beginning of modern observational astronomy. His invention of the telescope, though not the first, was revolutionary in its use, helping to expand humanity's vision beyond the limits of the naked eye. The instruments of a genius, Galileo's contributions weren't limited to astronomy. He was also a pioneer in engineering and design. In the late 1500s, he improved the military compass, a device that allowed gunners and surveyors to compute accurate measurements for artillery and surveying. His version of the compass wasn't just a tool for war. It was a symbol of the emerging role of science in both practical and military applications. Galileo sold more than 100 of these instruments, along with detailed instructions on how to use them, teaching others to see the world through the lens of mathematical precision. Galileo also made strides in thermometry, developing an early thermometer based on the expansion of air and water. By 1609, he constructed an instrument that would forever change the way we study the heavens, the telescope. It was through this innovation that Galileo turned his gaze towards the stars, bringing new insights into the universe. But perhaps one of his most famous, yet misunderstood, contributions was his work with pendulums. Galileo's experiments, most famously inspired by the swinging chandelier in Pisa's cathedral, revealed that the period of a pendulum, how long it takes to swing back and forth, was independent of its amplitude or the size of its swing. While this was an important discovery, Galileo's conclusions were a precursor to further refinements by others like Christian Huygens, who would later develop a true understanding of pendulum motion. Galileo and the speed of light. Galileo's curiosity didn't stop at the stars. He also delved into the very nature of light itself. In the 1630s, he attempted to measure the speed of light. His experiment, which involved two observers with lanterns, would eventually prove inconclusive, but it marked the first recorded attempt to measure light's velocity. While Galileo was unable to determine whether light traveled instantaneously or with finite speed, the experiment paved the way for future scientists to explore the mysteries of light and speed. A vision beyond the known world, Galileo's work, more than any other, bridged the gap between the ancient world and the modern age. He was not just a man of ideas, he was a man of action, putting his theories to the test through rigorous experimentation. He didn't just theorize about the laws of motion, he proved them. And in doing so, he laid the groundwork for the scientific revolution that would follow. His legacy is immeasurable. Galileo's relentless pursuit of knowledge, his willingness to challenge established norms, and his insistence on mathematical proof fundamentally changed our understanding of the universe. From the motion of the heavens to the physics of falling bodies, from the design of instruments to the study of light, Galileo's contributions remain integral to the way we view the world and the cosmos. His work inspired generations of scientists, including Isaac Newton, who would later build upon Galileo's insights to form the laws of motion and universal gravitation. Galileo once said, "In questions of science, the authority of 1,000 is not worth the humble reasoning of a single individual." His legacy proves that the pursuit of knowledge, driven by observation, mathematics, and reason, has the power to change the world.